Hello students, welcome back to my channel. I am here again to discuss questions which were asked on 31st January 2023 JEE mains. Okay, in continuation with the other questions, we have question number 45. You can see a microscope is focused on an object at the bottom of a bucket. If liquid with refractive index 5 by 3 is poured inside the bucket, then microscope has to be raised by 30 cm to focus the object again. The height of the liquid in the bucket is. Now suppose this is the bucket and this is the microscope. So initially it is focused to this point. Okay. And finally, when certain liquid was poured, let us say to a height h, which we have to find. Then this point is now here because image this is the actual object, but this will be the image. Okay, so this has to be raised by 30 cm is given. So we have to find h. So that this distance is h by mu. Apparent depth. This is the real depth and this is the apparent depth. So as we all know that shift is equal to real depth minus apparent depth. That is h minus h by mu. It is given as 30 cm. So 1 minus 1 by mu. 1 by mu will be 3 by 5. Therefore h is equal to 5 into 30 by 2. So 2 into 15, 15 5s are 75 cm. So the option is the correct option. Moving to the next question. Two Polaroids A and B are placed in such a way that their pass axes are perpendicular to each other. Now another Polaroid C is placed between A and B, bisecting the angle between their pass axes. Right. If suppose this is the pass axis of A, this is the pass axis of B, and in between there is another Polaroid, that is C. Okay. As you can see, the angle between A and B, passes of A and B is right angles. So for these it will be 45 degree each. So if now another Polaroid C, if intensity of unpolarized light is I naught, this is based on law of Malus. The first unpolarized light becomes converted into polarized light and the intensity reduces to half, that we all know. So when the light comes out through the Polaroid A, intensity is already I naught by 2. Then when it comes through C, okay, the angle between these two planes is 45 degrees. So according to law of Malus, I can write the intensity coming out through C as the intensity of incident light into cos square of angle between their planes of transmission. So which is equal to I naught by 2, cos square 45 degrees is half. So this will be 1 by 4, I naught by 4. Now that is the incident intensity of the incident light. Again the final intensity will be intensity of incident light, which is this, into again cos square 45 degree. Law of Malus. This is known as law of Malus. So cos square 45 is half. So finally it will be I naught by 4 into half, that is I naught by 8. So D option is the correct option. Moving to the next question. If a source of electromagnetic radiation having power 15 kilowatt produces 10 power 16 photons per second, the radiation belongs to a part of spectrum. Now students, here, in order to identify the part of spectrum, we have different techniques. If you know the frequency range, if you remember the frequency range, that is one way. You can remember the wavelength range. You can also remember the energy range, because each of these electromagnetic waves, they have their own range of energies or frequencies or wavelengths. Now it's up to you in which way you have memorized them. Okay, right. We can straight away find out in terms of energy. Now you see, the power of radiation is this much, and each second this much photons are released. So you can see the power is 15 kilowatt. Watt means joule per second, and number of photons coming out per second is 10 to the power 16. So we can find the number energy corresponding to each photon. Energy of each photon is equal to P by N, that is 15 into 10 to the power 3 upon 10 to the power 16. Okay, joule. So this is around 15 into 10 to the power uh, minus 13 joule. Okay. Now let us express it in kilovolt. Sorry, electron volt. So this will be 15 into 10 to the power minus 13 upon 1.6 into 10 to the power minus 19. So when you divide by the electronic charge, joule divided by electron energy in joule divided by electronic charge gives you energy in electron volt. So as you can see, this will be maybe somewhere around 10. I am not sure. Maybe slightly less than 10, because 16 tens are 1.6 tens are 16. So maybe 9 point something into 10 power 6. Okay. So this is straight away going in million electron volt. And if you are aware of the fact that only gamma rays have energies of the order of million electron volt, if you have solved any numerical related to gamma rays, you would have observed that their energies ranges in million electron volt. So without any problem, without any doubt, you can mark this as the gamma rays. Okay. Alternatively, as I suggested, you can find the wavelength or frequency to match with that. Okay. Suppose you find the wavelength, then wavelength will be somewhere lesser than 10 power minus 13 meters or 10 power minus 12 meters. That way. Moving on to question 48. Microwaves, we have to match the column 1, list 1 with list 2. So accordingly, so this is based on simple common sense. Okay. Now, X-rays have, amongst all these four electromagnetic waves, X-rays have the highest energy photons. So they are used to kill the cancerous cells. Okay. So X-rays are quite often used in treatment of cancer. Because of their high energy, they can be applied to kill the cancerous cells. Then infrared is often applied in physiotherapy. Okay, it's very common nowadays. It's very common. Most of us keep going to hospital because of our own problem or because of the problems of our relatives, friends, etc., etc. So physiotherapy means you get a therapy based on infrared lamp, that is a lamp releasing heat energy. Then ultraviolet rays should be mapped with laser eye surgery, and microwaves are commonly used in air navigation. So D1, A is 4, A is 4, B should be mapped with 3, B should be mapped with 3, C should be mapped with 1, and D should be. So B option is the correct option. Then, in a medium, the speed of light wave decreases to 0.2 times of its speed in free space. The ratio of relative permittivity to the refract index of the medium is this. Now, students, as we all know, That speed of light in vacuum is given by this as per Maxwell's theorem, Maxwell's law. Whereas speed in any medium is given by this. Okay. Now this itself mu m can be written as mu naught into mu r. Epsilon m can be written as epsilon naught into epsilon r. Okay. So which can finally be written as C naught upon under root mu r into epsilon r. Now from this we can see C naught by Cm is equal to under root mu r into epsilon r, which is nothing but the refractive index, which I will write it as n. Okay. So we have mu r epsilon r is equal to refractive index square. Now we have to find the ratio of relative permittivity and the refractive index. That is, we have to find relative permittivity epsilon r upon n, which will be n by mu r. Now mu r is given as 1, and refractive index can be obtained from the first statement. You can see the speed of light wave decreases to this. Now as we all know, refractive index is this. Sorry, I have used n, so let me use n itself. So this is given as 0.2 times of speed of light in air. So this will be 5. So answer is 5. X is to 1. X is to 1 is 5 is to 1. Then two light waves of wavelength this much are used in Young's double slit experiment to obtain interference fringes on screen placed 7 meters away from the plane of slits. If the two slits are separated by 0.35 mm, then shortest distance between from the central bright maximum to the point where the bright fringes of two wavelengths coincide. So suppose this is the screen. Let us say this is the central bright fringe. Okay. Let us say at some point the n1th bright fringe of this coincides with n2th bright fringe of this. As you can see, this distance will be same for both. Okay. So if I take this distance as some say L, then I can write L as n1 times of fringe width. I'll take the fringe width for this as beta 1 and fringe width for the 600 nanometer as beta 2, then this will be this. So n beta 1 is lambda 1 capital D by small d, whereas beta 2 is lambda 2 capital D by small d. So we have n1 lambda 1 is equal to n2 lambda 2. So lambda 1 is 800 nanometer, lambda 2 is 600 nanometer. Nanometer gets cancelled. We have n1 by n2 as 3 is to 4. Okay. You can take higher multiples also. Like if you multiply and divide by 2, you have 6 by 8. If you multiply and divide by 3, then 9 by 12 and so on. In other words, third bright fringe of this first wavelength, that is 800 nanometer, will coincide with the fourth bright fringe of the second one, that is 600 nanometer. Similarly, sixth bright fringe of this 800 nanometer will coincide with the eighth bright fringe of the 600 nanometer and so on. Okay. So they are asking the shortest distance. So we have to take this first situation. So this L we have to find. L will be 3 times of N1. 4n1, sorry, 4n1 or whatever it is, 4n1 or 3, anything is okay. So it is 3 times of n2, 3n2. Okay. n1 is 3, so 3 times of 3, sorry, what is that? 3 times of beta 1. So beta 1 is lambda 1 capital D by small d. So lambda 1 is 800 nanometer. Nano means 10 power minus 9. Capital D is 7 meters. I am proceeding in SI unit. Small d is 0.35 mm. 0.35 can be written as 35 into 10 to the power minus 5. So this much meter should be the answer. Later we can calculate this in millimeter. So 7 fives are, then we have 3 into 8. 5 can be written as 10 into 2 into minus 5 goes up becomes plus 5. So 5 plus 2 is 7. 7 minus 9 is this. So this entire thing will be a millimeter. So 6 8s are 48 mm. So 48 is the answer. That's all students in this video. Thank you so much for watching my channel.